Hello, this is a revision video for AQA A-Level Chemistry 1.1 Atomic Structure Fundamental Particles. This is a revision video, so only the essentials are covered. For deeper explanations and for full video lessons, please check the links in the description below and visit chemistrystudent.com. Atoms are the smallest indivisible units of elements and are made up of three smaller subatomic particles: protons, neutrons, and electrons. Protons and neutrons exist in the center of an atom in a dense region of space called the nucleus. Protons are positively charged particles, and the number of protons inside an atom determines its identity. For example, all hydrogen atoms have 1 proton in their nucleus, and all oxygen atoms have 8 protons in the nucleus. Protons, as well as being positively charged, also have a mass. Neutrons are neutral particles that don't have charge but do have mass. The number of neutrons in a nucleus doesn't affect the chemical properties of an atom, but does affect its mass. Electrons are negatively charged particles that exist around the nucleus in energy levels or shells. The arrangement and energy of electrons in an atom determines its chemical properties and behavior. The masses of protons and neutrons are very, very similar to each other. They aren't exactly the same, but they're so close that we don't really need to worry about their difference. So because of this, we assign them a relative mass of 1 each. Relative just means compared to each other. The mass of an electron is nearly 2,000 times smaller than the mass of a proton and neutron, meaning it's considered negligible and often isn't used in calculations because it's so small. The amount of positive charge of a proton is the same as the amount of negative charge of an electron, just opposites. So because of this, we assign a proton a relative charge of +1 and an electron a relative charge of -1. To summarize then, a proton has a relative mass of 1 and a relative charge of +1 and is found in the nucleus of an atom. A neutron has a relative mass of 1, a relative charge of 0, and is also found in the nucleus. An electron has a relative mass of approximately 1/1840 and a relative charge of -1 and is found surrounding the nucleus of an atom. The atomic number of an atom Z represents the number of protons in the atom. The mass number A is the total number of protons and neutrons. These are usually shown as a superscript and subscript next to the element symbol, with the mass number being the superscript and the atomic number being the subscript. But be careful because this doesn't have to be the case. Sometimes you'll see them the other way around. But always remember, the bigger number will be the mass number and the smaller number the atomic number. Isotopes are atoms of the same element but with different numbers of neutrons. For example, atoms of carbon-12 and carbon-13 both have 6 protons in their nucleus but different numbers of neutrons. Carbon-12 has 6 neutrons and carbon-13 has 7 neutrons. Because it is the number of electrons and protons that determines the chemical properties of an element, the different number of neutrons has no impact on the chemical behavior of these two isotopes, meaning they will behave identically in chemical reactions. It is only their masses that are different. The number of electrons will be the same as the number of protons in a neutral atom, so the atomic number will be the same as the number of electrons. However, the number of protons is always fixed for an atom, it can't change, but the number of electrons can. Atoms can lose or gain electrons to become charged ions. Cations are atoms that have lost electrons and become positively charged, because when they lose electrons, the number of protons in the nucleus becomes greater than the number of surrounding electrons, meaning an overall positive charge. Anions are atoms that have gained electrons and have become negatively charged. If an atom gains electrons, there are now more negatively charged electrons than positively charged protons, meaning a negative charge overall. Our knowledge of the particles that exist in an atom has changed and evolved over time. For example, Dalton's model in 1803 proposed that atoms are indivisible solid spheres. There was no mention or comprehension of subatomic particles. Thomson's plum pudding model in 1897 followed the discovery of electrons, and this model proposed that atoms were positively charged spheres with negatively charged electrons embedded within. This changed in 1911 with Rutherford's famous nuclear model. A gold foil scattering experiment showed that atoms have a dense positively charged nucleus, and the negatively charged electrons in an atom must surround this region of space. Bohr's model in 1913 further refined this nuclear model and proposed that electrons actually exist in quantized energy levels, what we now call shells. This was then superseded in 1926 by the quantum mechanical model, which actually proposed that electrons exist in orbitals which we can represent using probability densities.